I'm Jake and we're back in the Holland Built shop with another video powered by SendCutSend. Today we're going to be finishing framing in the lower parts of my quarter doors and adding a gas shock so that they automatically open up on their own. So with these door bars, I wanted to make it so it's an easy egress out of the car and into the car. And so what we ended up doing in a previous video is we ended up putting a hinge in here and a door latch setup, right? So this whole entire door can open up, latch close. This is gonna allow that passenger to only have to clear this bar instead of the upper bar. Though I am gonna run some window nets, the passenger and driver can get out through this window if they have an issue with the doors not opening in an emergency situation. But we now have this big void right here that I want to protect, something kind of coming through and getting into, like, say, the elbow of the passenger or the driver. And so what I want to do is frame in this little area that's going to kind of overlap this bar and kind of come up. And it'll just be a lighter framed area that'll keep sticks and stuff out. With that, I want to mount in a gas shock in here. This is going to kind of do two things. Going to add some pizzazz to the car, but it's also going to allow this door to be hinged open and stay open, making it easier for the driver or passenger to get in and out and not have to hold the door open while they're getting in and out. So what we have to do is we have to come up with a measurement here that when this is fully collapsed, we're going to end up having a hinge point here. And then when we fully open the door, that hinge point needs to be at the full extended of this gas shock. So we have a little bit of figuring out to do there. And then we also need to kind of figure out, as I put in these bars, I did a lot of measuring before I kind of welded them in, but we have a lot of measuring between the driver's side and the passenger side to make sure that all of these distance points, since they're kind of compound, we fully know where they're actually at. So what I'm gonna do now is I'm gonna take some of this chipboard that I used for prototyping, and we're just gonna open up, I guess we can slide it in here. We're gonna get it into the car, and I'm gonna just trace out this inner chunk here. And this is gonna allow us to kind of come back and fine tune it later on. So now we kind of have a general outline, but we have to remember that this is a compound kind of angle here. So this is going to be protruding back out towards us. So we'll do some extra measurements there. So I'm going to grab some scissors and we're going to cut this out and start kind of fitting it in there and get a better vibe of what's going on. Okay, so now that we did some really intense cutting of chipboard, let's go ahead and hold our template up here and see kind of how it fits. What we're looking at mostly is I want to make sure that I kind of have this angle demonstrated correctly. So let's look at that independently. We have a little bit of trimming up to do, but if we kind of hold it up, we're going to kind of see that internal shape kind of coming out. Mostly because since this bar is kind of coming back out, it's going to end up shortening up this as I bend it. We can kind of exaggerate that and see that it'll change those angles based off of how I'm bending it. So we're definitely shooting kind of in the dark right now, trying to outline this. I do have some models in CAD that can demonstrate what we did here when I did this door bar setup, but I also, each side's a little different, so I want to do a template before we waste too much material. This looks really close to me, so let's go ahead and add the next thing, which is I want to add this gas shock mount as just a point in space on this. And so what we're going to end up doing is I want to tuck this bottom mount as far back into this corner as I can. So I'm just going to go ahead and give myself a note to remind myself that I'm going to be putting in the gas shock mount somewhere back here. And then what we can do is simply have this gas shock mount kind of has to run underneath this door frame here. So that will hold. I'm going to actually mark this somewhere in here. So we need to make sure that this area is open for us on this quarter door. And that's going to allow clearance as that door shuts to go over this gas shock. And then we're going to be looking at having a mount somewhere in here. So now that we have that, let's go ahead and grab a tape measure, measure out from here to here to give myself a measurement in this direction. We're gonna go measure up to that other corner just to give myself some more information. And then we'll go reverse that into CAD to start trying to outline this door frame, what I'm thinking. And it'll make a little bit more sense. So one last measurement is I want to make sure that I get the amount of jog out that we have here with respect to like the center line of this pipe. And so what I'm going to do is I'm just going to take a straight edge that I have here. I'm going to line it up as close as I can to get to the centers. This is going to tell us a little bit more of the story. And then I'm going to measure out from out here to the center of the pipe. We're looking at about 4 inches. So I'm going to go ahead and mark that up on my template here. 4 inches out from center. So my goldfish memory will actually remember this. From center. Okay, and then we're also going to assume that all of these points are going to be at the center line of these pipes for the initial. What I'm imagining is that we kind of cope in a frame that comes up in here and runs down into this point. We have essentially another one that kind of comes up and copes in over this pipe, another one that copes in here. And since we have that gas shock, we can't actually register up against this pipe, but we have no clearance issues here. So we're actually gonna have this thing kind of come down, float off of it a little bit, and then we'll end up having another sheet that'll register up against this pipe to keep something from actually coming through and into the passenger or driver. So let's go ahead and take this template into CAD, start kind of reversing all these dimensions that I just got from here, and we'll start kind of dreaming up that frame. So going off of that chipboard design that we just did, I went ahead and reversed this entire design into CAD. And so if we look at the CAD here, I ended up getting that jog bend based off of this 4 inches out on center here on our template. And then I also reversed that triangulated points based off of this template. So this should be pretty accurate. I ended up checking this template on the other side of the car and it was actually pretty much the same thing. So I went ahead and made the frame, and you can kind of see here how I started laying this all out. I also have a gas shock in here. I reversed the gas shock, bottomed it out, and then that should be as it collapses we can have it on the closed door setting. This is the driver's door, but right now I'm planning on making a mirror image for the passenger door, but we're gonna go ahead and verify all that. And you can see here, I end up having 2 aluminum panels that I'm gonna have on the inside that go along with this frame. We're gonna go ahead and transfer this over to my CO2 laser and make it in hardboard before I go ahead and order it from SendCutSend. But the first thing I wanna talk about is that the holes that are on the inside on this frame here, I'm gonna be using PEM nuts, a hardware installation service that SendCutSend has to offer. And what that does is it allows us to have a thin sheet metal. I'm gonna be making this out of 74 thousandths mild steel. I can put a 440 tapped hole on the back side in a nut, but it's actually pressed into the material. And so what that does is allows us to, if we're looking at the material from a side profile and we have a hole, essentially that nut ends up having a crimped on setup that goes in here, where our threads for our screw are here, and then we have this crimping action, almost like a rivet, that comes through here, and then our hardware, so our bolt, will come through on this side, having our panel here. So this panel right here will be the flat aluminum panel, and then this will be that 74 thousandths mild steel. I think that they only go down to 40 thousandths right now in hardware installation, and that's based off of PEM's hardware guidance that's on their website. But if you go into SendCutSend's website and you go into the post-op processes, you'll end up seeing hardware install, and it'll actually resize your holes. So the holes that are in my design, I don't have to be spot on exactly the hole diameter for the correct crimping. Once I select this hardware, it'll resize the holes that are in my DXF to match the correct size for the crimping. So I don't have to even worry about having the right size here. They actually have that now for tapping as well, all that kind of changed. And so it's a new cool way that you don't even have to double check yourself on having the correct size for a tap or hardware. It does it for you. The last thing is that what they're gonna ask you is a hole insertion So if we're inserting the PEM hardware from this side or this side, we want to make sure that the hardware is on the opposite side of the panel that you're going to be screwing it to. And so if you're going to have, say, a nut, we're going to have a panel here. We want the hardware, like our screw, to be screwing through and pulling that hardware, the nut, through this material. And that's important because now we're relying on these shoulders as the force as that screw is trying to pull it through. Because if we were pulling the hardware back out this way, we're allowing just the crimp to keep that nut in place and it won't stay in there. So we want to make sure that that nut's on the other side. So when looking at my design here on the computer, we want to make sure that those hardware are installed on the outside of the car. As the screws are passing through this way, we're going to be pulling against it. If we go to SendCutSend's website, we have a 2D and a 3D view here for viewing. And then when we drop this menu down, we can select individual holes, or I have all of these as 130 holes, 1-inch 30 holes, or 0.130 holes. And so if I go down to hardware, select it, I can select any hardware. So they have studs, nuts, standoffs. If I select a stud 440 and I apply it, it's going to resize those holes to the correct size. And then we can see here you have top or bottom, and it's as pictured. So and this is what side it is inserted from, right? So hardware will be inserted from the top or bottom of the part as you're pictured. So right now, if we're going to want it on the bottom, and if we look at that, I can flip this part around and you can actually see, if we zoom in here, we can see the hardware and which side it's actually inserted on. So that's a good way to double check your design if the hardware specifically needs to be on one side. And then lastly, since I'm going to be probably ordering 2 panels that are exactly the same, but I need the nuts on each side, I'll upload these parts individually, but it'll be the same part number or part description. And then I'll put in my notes that the parts are mirrored parts. So the hardware just needs to be opposite from each other. That's a really good way to make sure that the operator has a lot of information. You can always add that stuff in your cart underneath the line item that you're having. You can add a description or a note. Adding it there will just give that operator that's inserting the hardware one more piece of information to work off of. So let's go ahead and create the DXFs, take them out to the CO2, make these parts to double check them, and then we'll get them to SendCutSend. We have a full template glued up that matches the CAD software that we just talked about in the office. And I took the liberty of just kind of gluing this up. So let's go ahead and look at a couple key points. First of all, the initial fit, I'm extremely happy about. What we're looking at is we need to make sure that this is somewhat flush. So we have a little bit of flex in here, and I think I'll still have that in the metal design, but we want this to be as close to being flush as possible. There's gonna be a body out here, but this is gonna have its own body panel, so we just don't have to have any rips or anything. The next thing is up here on this joint, we're as far forward as I could have gone, which actually makes me really happy. It just looks nice and clean. We're gonna end up having a little weld on the inside here, but extremely excited about how that looks. This frame is actually nice and flush on the inside. And then in the back here, we're tucked all the way up against where the door latch is. I'm really happy about that, as well as we're nice and parallel coming down on both front and back. So from a cosmetic standpoint, it looks really clean. Lastly, is I have those indexes holes up here. I'm planning on using the middle hole, but this allows me to have some flexibility on where the door is kind of coming in on the shut and open, so we can shorten how much it shuts. I can also run different gas shocks just in case these ones aren't working. The last thing is I have the mount for the bottom of the gas shock down here. I cut it out, but there's not really a reason to mock that up. I won't be able to use the gas shocks with this cardboard because it's not going to hold up to the force of the gas shock, and I have a lot of confidence in that design. So now what we're going to do is we're going to send this off to SendCutSend. The big thing is we got to remember that when we install the hardware on these, that it's on the outside of the vehicle or on this side, because our flat plate is going to come on this side that's going to actually box this in, and our hardware, like our screws, are going to come from this side. So they need to actually be the opposite side of the insertion of the PEM nut so that they pull the PEM nut through the material and not pull it out of the material. So as long as we get that right, everything's going to be good. So let me send this off to SendCutSend, and then we'll get back to the final part of this build. Okay, we got the metal parts hot off the press right from SendCutSend. We can see here, we have all of our PEMNUT hardware is installed on the back of our frames. They look awesome. These are gonna be 440 screws. What they're gonna allow us to do is that we don't have to have a nut on the back side of these parts anymore. We can just essentially put this frame right onto it. I'm gonna be vinyl wrapping these frames with a kind of a cool pattern. So we have a kind of a cool interior on the car. And so I can take these frames on and off. They don't need to be welded, and they're also a lighter weight aluminum than having it a full steel panel. But also protecting us from having, say, something coming through a little bit on the door. So I have our 3D template that we ended up making. I'm gonna be using this as a guide to make sure that I don't have anything reversed as I weld it up. But I think I'm ready. We're gonna start tacking it up. I'm gonna use the same procedure that I did on this to go ahead and transfer it to the metal and tack everything up. So light little tacks at the beginning until I get everything fitted and on the car, and then we'll go ahead and finish welding everything up. So let's get into the welding part. Okay, so tiniest little tacks that I put in here, that's gonna allow me to bend this back and forth. If I do it too much, they're gonna break. But what I wanna do is just kind of put this up in the car right now, double check that everything looks good. We're gonna come over here. And so I gotta bend these a lot more than I'd probably like. They seem to hold. So everything's looking just like it was on that template that we had. So I'm gonna go ahead and start putting in this back brace. And then we're gonna put in this one and hand bend in that joint. And then all light tacks right now until we have everything in place. And then we'll probably put some light tacks up here. We'll get that gas shock mount in, and then as we kind of get everything in place, then we'll start solidifying everything in. So I'm gonna go ahead and just kind of move through a bunch of welding now and get us further into this build. So now we're here to this hand bend portion. The reason why I'm gonna be doing a hand bend is because as we have to flex that joint, we're gonna have to kind of flex this hand bend in. So I'm hoping that all of these little tacks that I put in here are gonna hold long enough for us to flex everything in place, and then we'll throw a couple more tacks in here. So we can see here, I end up having these really, really small webs that are gonna allow me to just bend it. It's gonna end up folding right here at these weak spots. And so as we push down, we can see it folds nice and easy. And then we just have to work all of these materials in at one time. We have that one in now. And so now we have to just fold in one more. There we go. So now we can kind of see these kind of coming in here. I left a ton of room to allow us to have these come into place, but they should be centered up in these. So we have a little bit of massaging to do. So what I'm gonna do, kind of keep working these in and then tack them in. We're kind of at a point now where we're close enough that we can actually, oh, I just broke a tab. We can actually pick this up and actually see this in place a little bit. So let's go ahead and do that too. Make sure that we're not too far off. But, oh yeah, that's great. Yeah, that's awesome. So once we get these kind of established here and in, we're also gonna end up being able to pull all that in there. So actually that's right where we want it to be here. So a little bit more working to do. Yeah, that's gotta pull up. Broke that tab. So let me add a little bit beefier tab there, and then we'll start flexing that hand joint in, and we'll finish this thing up. So now that we have all of it all tacked up, I went ahead and put in the aluminum plates on the back side. I only have 3 screws right now kind of holding it in, but that's gonna allow any kind of flexing or twisting and stuff to compensate for those aluminum plates, making sure that everything's kind of fixed. The last thing is that I only have 3 small tacks right here. So right now I can kind of flex this thing in and out. So I'm gonna make sure that we have it as flush as possible to the outside of the frame here. And so I can kind of push that in, and then I'll put some tacks on the inside. I wanna do small tacks and small stitch welds throughout this entire thing to keep things from warping as much as possible. The last thing is that we have the inner mounts for the gas shock. we're gonna go ahead and tack these up and put them in, and then this is gonna be essentially a hammer bend. So I'm gonna tack them here, I'm gonna put it inside, and then I'm gonna hammer that down until it matches this chassis and finalize welding that up. We'll put that gas shock in, make sure everything looks good, and then we'll just finalize welding it. So let's go ahead and run through these last steps to finish this build. So all of it's tacked up. There's a lot more little welding to do, but I'm gonna take my time and move around so we don't have any warping. But the last thing is let's go ahead and test out this gas shock. So we're gonna open up the door. The easiest way to do this is gonna be to put the door, or put the gas shock in and then close the door. So let's put this in here. Things are still a little hot, so we have to burn ourselves. And then the other side's gonna go in on this side. I'm gonna go ahead and we'll tighten that stuff here in a minute. What we're looking at is, so now when we open up the door, opens all on its own. So I'm gonna go ahead, finish welding this up, and add the panels. I'm gonna do the vinyl wrap, and then we'll see you guys on the next build. Thanks for watching. Stay tuned for more.